All right, so the first rule we had is when you multiply two exponents with the same base, what do you do with their powers? You add them. Okay, so again, that doesn't change even if we're dealing with rational powers. Okay, also, if we take power to a power, so if we have an exponent taken to a different power, do you guys remember what we do with the powers? We multiply, so a to the power of m times n. Okay, another property that we've seen is the power of a product. Oops. So if you have some product, a times b or times c or whatever, any number of factors multiplied that are taken to a given power, that power applies to both or all factors of the product independently. Okay, so you can move them in, move them out. Okay, you can, for all of these, you can move back and forth between the different forms. Okay, we also talked about a negative power. What a negative power does is it flips the fraction. So it moves base from the numerator to the denominator or vice versa. So for this one, it would be equivalent to saying we take this base of a, move it from the numerator into the denominator, and change its sign to a positive power. Now, this holds true for a fraction as your base. If it changes, or if it takes this rational base, we'd simply apply the negative power, would flip the base, so it would become b over a, and it would stay to the power of m, and change the sign to a positive. Right. In addition to this, we have quotients of exponents. If you have two exponents with the same base involved in a fraction, you can simply do what with their powers? Anybody remember? Again, it's kind of like combining rule 4 with rule 1. The negative, if we move this base up, it becomes a to the minus n, and then a, here we'd be multiplying exponents with the same base. So we add their powers, m plus a negative n. Or the shortcut, simply take the difference of their powers. And then finally, if we took this form right here, we have a fraction as our base in an exponent. This power is going to apply to all parts of that base. So a to the m, b to the m as well. All right, so again, none of these are new to you. I believe we've talked through all of them. Hey, I just wanted to review them with you, and then if we take a look at some examples where you simplify using the properties of exponents, I want you to try these 3 examples for me, please. Right, I think for these ones, it's all pretty straightforward, though. The way that you enter it in your calculator should give you the correct answer on them, with the exception of maybe number 3, but we'll see as we go through these. Okay, the first one, if you just enter it on your calculator, x to the power of 2/3, make sure you put your rational power in parentheses or grouping symbols. And we're going to multiply that by x to the power of 1/9. Hit enter, and you have your solution x to the 7/9. Okay, and again, as you enter this online, x to the power of 7/9, your rational powers need to be embedded within grouping symbols. All right, problem 2. Again, if we attempt to enter it exactly as it appears, so grouping symbol 2 cubed times x to the power of 6, close my grouping symbol, take it all to the power of 1/3. Hit enter, and I have my answer 2x squared. Again, entering it online, pretty straightforward. And then the final example here, again, if we enter it exactly as it appears, x to the power of 3 over 4 divided by x, hit enter. And now, here's where it depends on what your answer looks like or what form it's asked. Okay, so this form right here would represent right using positive powers. Right? If it didn't specify this, it's very possible that you'd be asked to write it without using a fraction. And if you're asked to write this without using a fraction, you're going to apply this property of the negative power to move your base x up to the numerator. So if we wanted to express this as x with it not written in the denominator of a fraction, it becomes x to what power? If I don't want to write it in this fraction form using a positive power, what would move the x up to the numerator term? Good. So if you make this power negative, so this would be the alternate form. And so this would be writing without using a fraction. And now, this doesn't mean that x is not in the denominator. X still is in the denominator. And so it doesn't matter what form you write it. X is still in the denominator of this fraction. Only when we write it, we're not putting it in the denominator of the writing. So if you had to enter this, again online, x to the power of parentheses negative 1 over 4 would be the way that you'd enter that online.